Good morning. This is Manoj Kumar Srivastava, Assistant Professor in Department of Computer Science, AIML. And today I will be taking lecture on data structure. And this is first lecture. This data structure is being introduced to BTech students of third semester. And data structure is being a very important subject. And what are the textbook that is to be followed? It depends upon the student, but still there are some authors which can be utilized here in order to read and go through what are the data structure and what kind of data structure you have to study. This the textbook which has been introduced here are Introduction to Data Structure in C, because here in this semester we have to use data structure using C. That's why Introduction to Data Structure in C by Ashok and Kamte. And next book is Data Structures and Algorithm by A.V. Aho, or mostly we used to say that Ullman books, Hopcroft and Ullman. Data structure using C and C++, Langston, Augustine and Tannenbaum. Algorithm in C++ by Robert Sedgwick. But most of the book which is to be followed here is about the data structure in C and data structure and algorithm by Hopcroft and Ullman. Introduction. What are the course outline? This is the course outline which is to be introduced here today, and I will be covering the topics as given in here as enlisted here. Introduction to data structure, algorithms, recursion, stacks, queues, list and linked list, trees, sorting, searching, graphs, hashing. These are the following topics which will be covered during the session of data structures. And for today, introduction to data structure. What exactly the data structure is? And as we know that computer is an electronic machine and which is used for data processing and manipulation. When a programmer collects such type of data for processing, he would require to store all of them in the computer's main memory. That is the main issue or main concern for the any of the programmer who want to store its data. In order to make how computer work, we need to know the representation of data in the computer, as accessing of the data, and how to solve problem step by step. When it comes to solving a problem step by step, there comes a term algorithm. And for a programmer, as we will define what exactly the programming is, the programmer in terms of a simple equation, you can say that program is equal to, can we say that is equivalent to algorithm plus data structure. And here in this subject, we have to mainly be focused on data structure. Algorithm, as we already know that it is a step-by-step representation of a program. But here we have to focus on data structure. What types of tasks we used to do in the data structure, that we have to discuss here. Now we will start with what exactly data structure is. Instead of talking about the data structure as a whole, I will bifurcate these two words, that is data and structure. Data here represents collection of raw data. Why we used to say raw data? Because we don't know what kind of data we need while in our plan. That's why the raw data is most important here to consider prior to starting with the or implementing with the structures of the whatever memory area or wherever it is stored, that has to be represented. Only representation you have to follow here is the data. Now data structure is what? Data structure is a representation of data and the operations allowed on the data. That priorly I said that we have to work on the data structure which is mainly related to the relationship existing between the data and how it is being used and stored in the memory. Data structures are a method of representing of logical relationship between individual data elements related to the solution of given problem. That is again, when we talk about the related solution of the given problem, that means we have to priorly think of the problem and what kind of problem you are going to solve here using this data structure. Means it is purely based on the memory and storage. That's why we need to be very well versed with the this solution of the problem, so that it can be very easy for us to manage it, whatever data is present into the our problem. Now here comes what exactly the basic data structure we have to use here. um, in order to use the basic data structure, now what we have to follow here is we have to understand what exactly data structure is. And now data structures are divided into two types. It is primitive data type and non-primitive type. We already know during the programming of C, we have already come to know about that, what exactly the primitive and non-primitives are. Primitive are actually, it is a fundamental data types which are to be utilized in order to represent our data. And when data is represented, then we have to maintain using its existing relationship with the memory or the storage area. And non-primitive data are those data which are user defined or which can be created using the primitive data types. Now here in this lecture we will focus mainly on the non-primitive data, because data structure is here. We have to study data structure, and what kind of data we are going to prepare here, it is purely based on this only. Means whenever we will create a data structure that is non-primitive type, in that case we have to use the primitive data as well. Now the non-primitive data type is further categorized into two, that is linear data structure and non-linear data structure. When we talk about the linear data structure, what are the data structure we have to study or we have to follow here in a data structure subject is the linear data structures are arrays, linked list, stacks, queues. All these are the data structure where you have to follow. Again, in case of non-linear data structure, it consists of trees, graphs, and hash tables. Now comes here the exactly difference between linear and non-linear data structure. So we have already know about the data or basic data types, what are you have to use here in data structure related to linear data structure and non-linear. Now what is difference is here, every item is related to its previous and next item. In case of linear data structure, means every data will be related, either it is previous data or its next data, which is to be considered here. In case of non-linear, every item is attached and with the many other items. That means many other items means what, it is not necessary that we have to directly attach with the previous or next item. The next item could be anything, anywhere, as per according to the data structure which we have defined here. Data is arranged in linear sequence in case of linear data structure, but in case of non-linear data structure, it is always scattered, means it is not in sequence. The data is not arranged in a sequence manner. Data items can be traversed in single run. This is the most important part of the linear data structure which is to be considered here. Whenever data we are going to traverse here, we have to linearly traverse here, and it can be traversed in a very single run. That is array, stacks, linked list, and queue all can be traversed in a single run. But in case of data that is non-linear data structure, it is not possible because it consists of tree, and trees have many branches. That branches can be backtracked and then come to the again to the main track. So it is not possible to sequentially or traversed in a single run. It takes lots of time also, and possibly it takes many turns in order to process all the whole the tree. In case of linear data structure, implementation is easy, but in case of non-linear data structure, implementation is tough and it takes time. Now these are the graphs and diagrams which represent different data structure which we have to study here. The first one represents, that is, first one represents, if we come to know all about this one, that is, see, if we talk about the array, here what exactly is, this is the array, and representation of array is, it is a diagrammatic representation here now. And when we talk about the data structure here of array and a definition of the array is what exactly, it is a homogeneous data type. It is a homogeneous data which is placed or which is stored in a memory in continuous form. That is all, as we know that it is a linear data structure, so all the data will be stored in a linear manner. Means starting from the first data, that is this one, if we say, so it will start from here, this will be the first data, and after that it will traverse to the either forward direction or a backward direction. In case of forward direction, next value will be the data, and similarly it will proceed. Again, another linear data is linked list. Here again it has been so that this one holds the data. Linked list means it can be said that here, that with the help of this arrow pointer, we used to point what data is to be come in the next as compared to the first of the data. So this is the linked list. This is the manner how the data are stored in the memory in case of linked list. Linked lists means which is a group of data where all data will be stored, or it can be say that it is a homogeneous data which is to be stored here and connected with each other with the help of data addresses. Whatever data we are storing at the particular location, it has some addresses. That address points to the next where the value has been stored for the next data. This is how linked lists are maintained. Now if we come to see another linear data structure is stack and queue. In case of stack and queue, whatever comes in, means in case of stack, what happens, the last in first out, means in case of stack, whatever we will insert the data, it will always come from the top of the stack. That's why as the arrow is shown here, this one is incoming of data, and this one is outgoing, means popping up of data and pushing up of data. So here whatever the last data will be, it will be placed in the stack in such a manner that the first data will be the last data, and the last data will be comes out as first. That's why it is treated as a stack. In case of queue, it follows the concept of last in first out, because every time we have to push the data in order to replace with another data. In case of Q and DQ, we will be using Q and DQ, and when Q enters data, it takes the first position as it has been shown here, and when the next data will arrive, this first data will travel to the next position, and similarly it will be reach at the first, means first come first serve, means whatever the data will be firstly queued here, that will be come out as a form of data which is to be represented here with the help of queue. But in case of tree, what happens, tree it is a non-linear data structure. It has different branches into it, means multiple data are stored at a different locations. So when we will traverse here, we will consider only one path. After completion of this path, again we will reverse back in order to reach to the particular data, means previous data, and then we will again move to the next data as per the diagram. That's why traversing here is not simple and easy. It takes much of the time in case of processing, and also we follow the concept of backtracking in order to traverse all the branches of the tree. Now the important point is what means on a data structure, exactly what kind of operation we are going to implement on the data structure, or what kind of operation we are going to perform on the data structure. So as per operation of data, we can see here in the presentation that design of efficient data structure must take operations to be performed on the data structure into account. The most commonly used operations on the data structures are categorized here. And what are the data structure operations in case of this data structure we have to follow here is first one as represented here is create. Means you are going to create a new data structure, you can see. The operation results in reversing memory for program elements. This can be done by declaration statement, creation of data structure, may take place either during compile time or runtime. This is an important part. Means either during compile time or at a runtime. Declaration statement, creation of data structure may take place either during compile time or runtime. Why? Sometime we already know that what we have to create compile time, that is during the compilation it will detect what kind of data structure we have created here. But sometime what happens, we don't know what kind of data structure is needed for storing some of the data, and that will be stored here or that will be created dynamically. That's why runtime compiler is, and for processing that type of data while creating it, we used to consider it as a runtime operation for that kind of data which is to be created here. Next is destroying or deleting. We can say that whatever data is being created, most probably after use, may be possible that after a number of times of use it has to be destroyed or it has to be removed in order to free our space. So that's why a destroy operation is here in this case. So this operation destroy memory space allocated for a specified data structure. That is important, because we have to release the memory space also, whatever the memory we are utilizing here. Because if we are continuously going to utilize all the memory and leave it intact, in that case what will happen, the memory will get flooded with a large number or large amount of data, which will be very difficult for any of the programmer to utilize that particular memory area. So after utilization, after using, may be possible that this data should remain for a longer, or it may be for a lifetime, or it may be for longer interval of time, or possibly it can be that data which has been created maybe for short interval of time. In that case, all those data which are for short interval of time, that has to be destroyed priorly and efficiently, so that we can utilize the data structure. Next comes the selection. Whatever data has been created here, that has to be utilized by the programmer or the user, whoever going to use that data structure. So there is a selection process which help us to utilize the data structure that has been created. Now what exactly the selection is? This operation deals with accessing a particular data within a data structure. That means whatever data structure has been created here, that has to be used and accessed as per our need, as per the need of the programmers. Possibly whatever data has been created here, that data may be sometime modified, or whatever earlier was written over there, that has to be rearranged. In that case, what we have to do here is operation is there, that is called updation operation. This updation operation will help us to update or modify into the data whatever that data structure holds. So in order to modify that data, we use updation. Next comes the searching operation. Why searching is needed? When large of amount of data is created and being stored in our data structure, after some time or after query of some of the user or after the query of some of the specific person for which data has been, our data structure has been created, he need to know about the his or somebody else data that has been stored in the memory area, and what is the operation which will help you to access or to find out that desired data. That data can be accessed with the help of searching. Its presence can be desired its presence for a desired data can be accessed from with the help of searching operation, and it finds the desired data into the present into the data structure. It also finds out the location of the element that satisfies certain condition where the data has been located. That's why searching operation name is given here. So searching helps in finding out the location of the element that satisfies the criteria of the criteria or the condition of the particular data that is to be that is desired by the user or desired by the programmer. Next come whatever data is stored into the data structure is possibly we have to maintain it by in a certain order, and in order to maintain that kind of that particular order we need, and what kind of order it can be. It can be either in descending order or ascending order if it is a numeric data type, but in case of character it can be in ascending order or descending order as a character wise alphabetic order. So it depends upon the programmer that how he want to store or operate on the data or sort on the data so that it can be maintained. That's why another operation comes here, that is sorting, and sorting helps in accessing those data in either in ascending order or in descending order. Sorting helps in maintaining even alphabetic order also. So data structure is needed. There is program we have to write it for maintaining the order either in alphabetic order or in numeric, that is ascending or descending order. Next comes the next operation, that is splitting. When a large amount of data is being stored into the memory, and possibly it can be a single list or multiple list. In that case what happens, much of the database or data stored into the memory is to be divided into two or multiple parts so that any of the operation to be performed on that particular data can be made easy, and this is possible with the help of operation that is called splitting operation. It is a process of partitioning single list to multiple list. Means a single list which is a large amount of data that is being created into a different small chunks which is called as a multiple list and splitted and stored into your memory or in computer's memory storage area. One more operation is there. When splitting comes here, it is possible that we have to or we need merging of that particular data. So how we are going to do that operation? This can be done with the help of operation called merging operation. What it does, it takes two different lists and merge it into a one list and produce in front of the user or the programmer where it has been needed. So this is the operation. Merging is the operation where processing of combining the data items in of a two different lists into a single list. Next comes very important, as we have already talked in the previous that is presentation, was traversing. Traversing is also a very important operation for a data structure where we have to simply move and or we can say move and visit to the particular location in order to check that particular node carries that data or not. So this process is called traversing. Means it is a process of visiting each and every node of a list in the systematic manner, we can say that. Now, after understanding about the operation of the that is called data structure operation, what kind of operation we have to perform on the data structure, here comes the first uh, what we have studied in the last presentation. I will be elaborating more related to the data structure here in this part, that is called selection of data structure. Now it is very important that what kind of data structure, as there are two different data structures which is to be utilized most of the time, that is linear data structure and non-linear data structure. But what kind of data structure we are going to consider, or what kind of data structure we are going to utilize, or what kind of data structure we are going to select, the choice of particular data model depends upon the two consideration. First one is rich enough in structure to represent the relationship between the data elements. Now relationship is the very important part of the data structure, what we have to, while we have to consider the selection process. Means which data we have to consider, which data we have to store in our data structure, what kind of data structure we have to create in order to store this data structure. Is there any relationship, or is there any data related to each other? That is what we have to understand. Means priorly I have talked about that we have to know each and everything in order to design our data structure. And while talking static and dynamic type of data structure, a compile time or runtime of data structure, the priorly knowing each and everything about the data, it will be easy for a programmer or a user to understand what kind of relation we have to make here, or where we have to store that data. That is the important part. That's why the first point is given here, that it must be rich enough in a structure to represent the relationship between the data elements. Next one is that on what criteria, on what basis we have to select the data structure. The structure should be simple enough that one can effectively process the data when necessary. This is also a very important part. So that's why these two are the very important part of the data structure while selecting what kind of data structure we have to prepare here, or what kind of data structure we are going to utilize here. This first one was we have to check the relationship between the data elements, and second is it should be simple enough, or we can say that it should be readable enough that anybody can understand that this is the data structure, this is the particular data structure which we needed here. Now I will be explaining about some of the basic concepts of the data structure that has been explained earlier, and what are the properties it holds. This is the example of a linear data structure. Here in linear data structure, values are arranged in linear fashion. That means I have already explained while displaying the graphs of different data structure or images of the data structure. In that case, what kind of value was stored and how was stored. So first comes, in case of linear data structure, is array. This array holds fixed size data. That's why it is called. That's why it's very important here that if, and after this one we will continue this lecture in the next session. Thank you.